Hello class, this homework assignment is directed to putting into practice the skills you have recently acquired, I hope, in which you're going to determine how many protons and neutrons and electrons are in an atom based on what the symbol says. Also, I'll show you how to combine ions to give you an ionic compound. Normally when you combine two sets of ions to form an ionic compound, the result is not going to have a charge. So how do you do that? We're going to try a couple of problems. And these are the odd-numbered problems on the assignment I put on the website. So your homework this weekend is to do the even-numbered problems. Let's hope you catch on. But if you don't catch on, watch this video a couple times until it makes sense. So the first question, 247, is a table where they give you a symbol, and then they ask you to fill in the gaps in the table. So for example, cobalt, which is element number 27, has a mass number of 59, and this particular cobalt atom has a charge of +3. So what does that tell you? What does this symbol tell you? It tells you you have 27 protons, because that's what the atomic number tells you. How do you get 32 neutrons? Well, you subtract 27 from 59, and that's what you get, because the mass number is protons plus neutrons. So if you subtract the protons, you're left with the neutrons. That's how you get that number 32. How do I get 24 electrons? We're told the atom has a +3 charge. If it has 27 protons, if it had 27 electrons, it would have 0 charge. But because it has a +3 charge, it means there's an excess of 3 protons, which means it lost 3 electrons. So that's why I can put down 24, because 3 less than 27 is 24. And then, of course, the net charge is +3 because it tells you right there. In this one, we have selenium. Actually, we don't have that. In this table, what they start off with is this 34, the 46, and the 36. So if you have 34 protons, you could put that number in right away. So right away, you could look it up on the periodic table. If it's element number 34, it's selenium. Then they tell you there are 36 electrons. So if you have 2 more electrons than you do protons, you know it's going to have a -2 charge. And finally, if it's if it's selenium, its mass number is going to be 80, which you can find from the periodic table. So then it has to have 46 neutrons, because 34 plus 46 gives you 80. And of course, the net charge is -2. On the third example, they give you the net charge, the number of neutrons, and the number of protons. So if they give you these two numbers, you can find out the, what have I written here? Oh, it's osmium, right. 76 plus 116 gives you a mass number of 192. Element number 76 is osmium. Let me just double check. I was bumping into this chair. Yeah, it's osmium. So 76 protons. And then because it has a charge of +2, it means it's missing 2 electrons, so it'll be 2 less than the number of protons, or 74. Finally, in the last example, they give you these 3 numbers: the number of protons, the number of neutrons, and the number of electrons. So it's missing 2 electrons compared to the number of protons. So its charge is going to be +2, and I didn't write that here. Okay, so it's got a +2 charge. And yeah, then you write down here +2. 78 electrons to have a +2 charge, and the number of neutrons is 120, because it has a mass number of 200. Or rather, 80 plus 120 gives you the mass number of 200 for this particular isotope, because it can happen that you get varying numbers of neutrons for different isotopes of the same element. For instance, if you have uranium, which has an atomic number of 92, but it can have a mass number of 235 or 238, depending on how many neutrons it has. So one type of uranium is the fissionable type. It's fairly highly radioactive, and it's used for making atomic bombs, and it's used as reactor fuel. And then the 238 version of uranium is actually very low in radioactivity, and it's called depleted uranium because what happens is they've taken the 235 out of it. And the 238 is often used for making bullets because uranium is the same density. Actually, it's even denser than gold. Density of uranium is 18.9 as compared to 11.4 for lead. So it's a very heavy metal. It's perfect for making bullets because the bullets will fly a longer distance if they're denser because they retain their kinetic energy better. So the American Army has a lot of what's called depleted uranium bullets. They use it in their phalanx guns for as a sort of deterrent to missile attacks on ships and other sort of last resort defenses against ballistic missiles. It's an interesting metal too because when it hits something, it's pyrophoric. It gives off fiery sparks, and then the oxides of the metal can be particularly toxic. There's some rumor that the uranium residue that was left behind during the Gulf War, I already brought it, the uranium residue that was left behind in the Gulf War was causing some of the soldiers to come back sick because of the exposure to the oxides of uranium, which are quite toxic on the battlefield. And it wasn't because of radioactivity, it was because of the fact that the oxides themselves are toxic. Okay, so the next one is 249. It says, using the periodic table, predict the charges of the ions of the following elements. And the way you predict the charge of an element is you look at its place on the periodic table, and whatever group it's in, that'll tell you what charge it's going to get. And if that doesn't work for you, what you can do is look at the element's position on the periodic table and ask yourself how many jumps you have to do to get to the closest noble gas. So let's do an example. For example, strontium. Strontium is a group 2 metal. So to get to the closest noble gas, which happens to be krypton, you'd have to do 2 jumps. So the charge on strontium is +2. It's also a group 2 metal, so +2. All these guys like to have a +1. All these like to have a +2. All of these like to have a +3. And for obvious reasons, because they're that many jumps away from the closest noble gas, because noble gases have the most stable electron configuration, and that's the configuration that atoms like to adopt when they form their ions. So, and also keep in mind, metals tend to lose electrons to achieve a stable octet, whereas nonmetals tend to gain electrons to achieve a stable octet. Phosphorus typically will have a charge of -3. Why? Because it is 3 jumps away from the closest noble gas, which it will imitate when it acquires a charge. So phosphorus will gain 3 electrons to gain a charge of -3 and to gain that stable octet. Iodine will gain 1 electron to become isoelectronic to xenon. And lastly, selenium will gain 2 electrons to become isoelectronic to krypton to attain that octet configuration. So that's what I have written here for the answers of 249. Okay, and it's always to resemble the configuration of group 18 to achieve what's called a stable octet. The next example is number 251. Mind you, these are the odd-numbered exercises. Your homework is going to be to do the even-numbered exercises. So that's where you're going to prove to me that you actually learned this. So 251, it says, using the periodic table to guide you, predict the chemical formula and name of the compound formed by the following elements. So gallium and fluorine. Gallium typically has a +3 charge. Fluorine becomes fluoride with a -1. So the +3 and the -1 combine so that there's no charge in the ionic compound that forms. So it'll be GaF3 or gallium fluoride. Lithium will combine with hydrogen. If the hydrogen becomes a hydride, meaning the hydrogen gains an electron, the lithium will lose the electron and you get lithium hydride. Because one is +1, the other one is -1, one of each combines to form a neutral substance. Aluminum typically has a +3 charge, iodide has a -1 charge, so you're going to get 3 iodine atoms combining with 1 aluminum to form aluminum iodide. Potassium usually has a +1 charge. Sulfur forms a -2 charge when it turns into sulfide. So 2 potassium atoms will combine with 1 sulfide. Sorry, 2 potassium cations will combine with 1 sulfide to form potassium sulfide. 53. Predict the chemical formula for the ionic compounds formed by calcium ion, 2 + 2, and bromide anions, which are -1. So you're going to have 2 of the bromides and 1 calcium, so you get calcium bromide. The second example, you have a +1 for potassium. And again, you look at the periodic table to tell you what the charge on the ion is. That's why I make you memorize the periodic table, so that this becomes almost second nature for you. If you don't know where the atom is located on the periodic table, you're not going to know what charge the atom has, and then it's pure guesswork. So if you do know where the position of the atom is on the periodic table, it does disclose quite a lot of useful information about what the atom normally does. So potassium is normally +1, carbonate anion is a -2, so you're going to need 2 potassiums to combine with the 1 carbonate to give you potassium carbonate. Aluminum is typically +3. The acetate anion is -1. You probably won't recognize this if you give it a quick glance, but this is why I'm telling you to memorize your polyatomic ions. And your homework when you're going to come back, or actually should be the homework you do over the course of this week. But next week when you come back to class, it's going to be your turn for the grade 10s. So you're going to be making flashcards and writing down the polyatomic ions on them. And you should probably get started. I have a few flashcards here at the front of the desk, which I will give you, but you can also make your own cards, or you can buy the card stock yourselves as well. Anyway, -1 for acetate, and aluminum is +3, so 3 acetates are going to combine with aluminum, so you're going to get aluminum acetate. D, ammonium is +1, sulfate is -2, so 2 ammonium cations combined with 1 sulfate to give you ammonium sulfate. And finally, magnesium with its +2 charge and phosphorus with its -3 charge. You're going to get 2 phosphoruses at -3 to give you -6 total, and 3 magnesiums at +2 to give you a +6 total. And those 2 will combine to form a neutral compound, giving you magnesium phosphate. Lastly, 255, predict whether each of the following compounds is molecular or ionic. The best way to do that is to assess whether they're far apart on the periodic table or close together. If the 2 elements that are forming the compound are far apart, they're going to be ionic, by and large. If they're close together on the periodic table, they tend to be molecular. So, for example, 255A, I only wrote down the answer. I didn't. I'll put the chemical down as well. Diboron hexahydride. Boron and hydrogen are, well, they're not too close together on the periodic table, but in fact they are molecular. It's a molecular compound. B, methanol. Definitely a molecular, it's an organic molecule, it's molecular. C, lithium nitrate is definitely ionic because the nitrate anion has a minus charge and the lithium cation has a plus charge. So they're attracted to each other and they form a matrix like all ionic compounds where they stack one after another, one plus charge and then minus charge, plus charge, minus charge, and so on until you form a big layer of interspersed plus and minus charges. D is scandium oxide. Scandium is over here and oxygen is over here. They're far apart on the periodic table. Oops, you can't see me. Hold on. Let me do that again. Scandium is over here and oxygen is over here. So that's far apart on the periodic table. That's an ionic compound. SCO. SC203. E is cesium bromide. Again, they're far apart on the periodic table. Cesium is a metal on the left-hand side on group 1, and bromine is in group 17. They're about as far apart as they can be, so they're going to be ionic. F is NOCl. That's a molecular compound. Nitrogen, oxygen, chlorine are all grouped together very close on the periodic table. G is NF3, again a molecular compound. Nitrogen and fluorine are pretty close together on the periodic table. And lastly, you have silver sulfate. Sulfate has a -2 charge. Silver has a +1 charge. That's an ionic compound. And that's it for today, folks. So use this to help you answer the questions, the even numbered questions in the homework assignment I gave you if you're in my class.